all your clients. Okay. All right. So we'll understand how this happens. First of all, what is DHCP? So DHCP stands for Dynamic Host Configuration Protocol. It is a network management protocol. Okay. Used in networks to dynamically assign IP addresses and other configuration. What is other configuration? IP address will be assigned. Along with the IP address, you can assign information like your default gateway. You can assign DNS server. These kind of information, also subnet mask. These informations also you can assign with the help of DHCP server. Okay. Like your default gateway, mask, and DNS server, etc. So DHCP is a application layer protocol. Okay. And works on which protocol? UDP. And port number 67 and 68. So for server, we'll be using 67. For client, we'll be using 68. Means if any message is going for clients, it will be going for port number 68. If any message is going for server, it will be going for port number 67. DHCP server automatically assign IP address to various devices in the network. This in turn reduces the work of network administrator to manually assign IP address to various devices. This part is clear, right? So automatic IP address assignment process undergoes 4 messages exchange. There are total 4 messages that are exchanged. They are discover, offer, request, and acknowledgement. And in short, we call this process DORA. Okay, discover, offer, request, and acknowledgement. So now what is going to happen exactly? Let's say this is a small network, and these are the 2 systems. So on the router, let's say you have assigned configured DHCP server. Your router is acting as a DHCP server. This is PC1, PC2. MAC address A, MAC address B, and let's say MAC address C. This is clear. Okay. Now on router, we have configured DHCP server. Whenever you go on these clients and set the IP configuration to automatic, the first thing that is going to happen is your clients are going to generate a discover message. Your clients are going to broadcast a discover message. Why they are going to broadcast? Because your systems are not having the IP address. So if they are not having the IP address, they do not know where the server is, right? So all the DHCP messages, all these 4 messages, discover, offer, request, and acknowledgement, these are all broadcast messages. Okay. So this message is a broadcast. So why this discover message is being used? This message is used to discover your DHCP server. If a DHCP server is available in your network, to check whether a DHCP server is available in your network or not, we have discover message. Okay. So once this discover message is sent by a client, this is a broadcast message. So what is switch is going to do? It is going to broadcast it, or it is going to send it out all the ports except the port that it was received on. Okay. Means your switch is going to forward it this side as well as this side. So this system, it is going to drop this message. Why? Because this system is not a DHCP server. Okay. So this system will drop the message. Now your DHCP server, your router received the discover message, right? Let's say this is discover. Router received the discover message. Now router DHCP server. Guys, please mute your mic. Okay. So your DHCP server is going to make an offer for the IP, because your DHCP server has the information what are the IPs available. Okay. In the DHCP server, it has assigned the IPs, and the free IPs, it has the information that, okay, next IP free is this one. So it is going to make an offer. So again, the offer packet, it will be again a broadcast. Why? Because your DHCP server doesn't know where is the client. Your DHCP server doesn't know where is the client, and your client is still not having an IP address. So this will be your offer message. In the offer message, your DHCP server is going to say, this is the IP, this is the subnet mask, this is the default gateway, and this is the DNS server. Means this is the IP information I can provide you. Again, it is a broadcast which is going to forward it this side as well as this side. This is the offer message. Now, again, your this client, if it has requested for the IP, it is going to accept. But if it has not requested for the IP, it will not accept this packet. Okay. Means again, this message will not be accepted. And this client, it has received this particular offer. Now, first of all, before using this IP, it is going to send a ZR to check whether the same IP is being used in the network. Okay. It will send a ZR to check whether the same IP is being used in the network. So it will check. So if it receive reply for GR, that means same IP is used in the network. If it does not receive, because in case of your GRP, if you remember, your GRP is a type of message that is basically a ARP response, not a ARP request. So there will be no reply. First thing. Second thing, it is going to do what? In the source IP and the destination IP field, it will keep the same IP. So if the same IP is available in the network, they are going to reply. Okay. So when it does not receive IP, next what it is going to do, it is going to send a request. Means the request is basically nothing. You can say your PC1 is going to send an agreement of acceptance. It is going to say, okay, I'll accept this IP because this IP is not being used in the network. Okay. So again, this will be a broadcast, and this will again be dropped by this system and go to the server. Once the server sees the acceptance, server is going to do what? Server is going to make an entry in the DHCP table. There is a DHCP binding database. Okay. In that database, it is going to make an entry that this IP I have assigned to this MAC address. Okay. Then after that, it is going to acknowledge. It is going to acknowledge and it is going to tell the client, okay, I have made an entry. Now you can use this IP. And these are the total 4 messages. First, discover. Second, offer. Third, request. And fourth, acknowledgement. In the discover is used to discover your DHCP server. With the help of offer messages, your DHCP server is going to make an offer for the IP address. Then your client is going to check whether the same IP is being used in the network with the help of ZR. And if the IP is not being used, your client will show the acceptance with the help of a request packet. Once client show the acceptance, your server is going to make an entry in the DHCP binding database, and it is going to acknowledge that now the client can use the IP. And after this particular point of time, your client will start using that particular IP, whatever IP is that. Let's say 10.0.0.10. Is it clear? Yes.
So when you say that when the DHCP server offers the IP address to the client, is it like something actually or is it going to
One address, because one client is going to need one address only.
the choice is up to DHCP?
Up to DHCP server. The next free IP DHCP server is going to provide.
Okay.
Okay. All right. Clear? Any more doubts? No? Okay, then we'll see these messages.
It's not send pool of IP addresses.
Hmm?
Our server not send a pool of.
No, just a single address.
Receive multiple requests,
Then multiple offers it is going to make. And see, let's say again, the same scenario. These are 2 systems. Again, this is your DHCP server. Okay. This is your PC1. This is your PC2. Let's say both of these systems, they make a request. They are sending a discover message. So server will receive 2 discover messages. Server is going to make 2 offers. Okay. Now, whichever client accept whatever offer, they'll take the offer and send the request message. Okay. So if let's say it is for .1 IP and it is for .2 IP. So if this system first accepts the .1 IP, then this will take the .1 IP. Because again, before using the IP, they will send ZR to check whether the same IP is being used. So if before PC1 has taken .1 IP, what will happen? When PC2 is sending the ZR, it will find that, okay, it is already being used. So it will take the next offer. Okay, this is one scenario. Second scenario, if you have more than one DHCP server. If you have more than one DHCP server, so again, if they will make a request, it is a broadcast packet. So means this server is also going to make an offer. So these clients are going to accept the offer that reaches first. They are not going to decide that, okay, I'll take this server only or this server only. No, they will accept the offer that is reaching them first. Clear? Both the scenarios? Yes or no? Online people? Okay. So these are the 4 messages in short. So discover message, this is sent by the DHCP client to discover DHCP server. Then offer message sent by the DHCP server to lease unique IP address and other parameters to the client. Then request message sent by the DHCP server asking server to lease parameters listed in the message, because your client will show acceptance that I will accept this, so please lease me these IP addresses. And whenever your server sees this particular message, it is going to make an entry in the database and going to give an acknowledgement that you can use this IP. So acknowledgement is sent by the server to assign IP address, mask, default router, and DNS information to the client. Clear?
All time broadcast.
Why broadcast? Because your client will not have an IP address until or unless they are done with this acknowledgement. Okay, clear? Then this is the detailed information about each and every message. The first is DHCP discover message. This is the first message generated in communication process between server and client. This message is generated by the client to host or to server in order to discover if there is any DHCP server or servers are present in the network or not, just to discover whether the DHCP servers are available or not. This message is broadcasted to all devices present in the network to find DHCP server, because it does not know about the DHCP server. And this is the size, either 342 or 576 bytes. Okay, variable size. Then next message we have is offer message. So this offer message is what? The server will respond to the host in this message specifying the unleased IP address. Means whichever next IP address is free, your server is going to lease that IP address. It is going to provide the information about that particular IP address and other TCP configuration information. This message is broadcasted by the server because again, client is not having the IP. So anyhow, if the server has to reach the client, it has to send a broadcast. Size of this message is 342 bytes. If there are more than one DHCP server present in the network, then client to host will accept the first DHCP offer message it receives. If you are having 2 or more than 2, the first offer that reaches the client is going to accept that particular offer only. Okay. Also, a server ID is specified in the packet in order to identify the server. Server will also give the information about its own IP, that I have provided you this IP, because whenever you get IP from DHCP, your system knows from where the IP has come. Okay. You can check. Whenever you check IP configuration in your system, And if you go to the details, you'll find IPv4 DHCP server. So there is always this information. The server is going to provide their own IP address also, that I have provided you this IP. Okay. This is the offer message. Then we have the DHCP request message. So when a client receives an offer message, it responds by broadcasting a DHCP request message. So it is going to respond to the offer message by a request message. The client will produce a grep in order to find if there is any other host present in the network with the same IP address. If any other host is using the same IP address. If there is no reply by other host, then there is no host with the same TCP configuration in the network, and the message is broadcasted to the server showing the acceptance of the IP address. Client has verified whether the same IP address is being used in the network or not. If it is not being used in the network, then what your client is going to do? It is going to send a request message and show the acceptance to the server that, okay, I'll accept this IP address. Okay. A client ID is also added in this message. Means in this message, the client will specify its own MAC address also, that this is my MAC address. So whenever this message reaches to the client server, your server is going to attach that particular MAC address with the leased IP address, and it is going to create the database. Yes, after the acceptance. Because until acceptance, your server is not going to know that to which system it has to assign the IP.
Since the acceptance message, in that only the MAC address.
MAC address will be present before also. Source MAC will be present, but server will not add it in the database. Okay, server will add only after the confirmation, after the acceptance, that okay, it has accepted this IP, so I'll give this IP to this person. Okay. Then the final DHCP acknowledgement message. In response to the request message received, the server will make an entry with the specified client ID and bind the IP address offered with the lease time. What is this lease time? This lease time is the duration you can use an IP address. Means if server is providing an IP address, so it will also provide you a lease time, that for this particular period of time, you can use this IP address. Okay. After that, the client has to request again for the new IP address. It will release the IP and it will place a renew request. Okay. So you can see, whenever you get the IP address, you get the lease time also. This is the lease obtained at 8/8. And what time my lease will expire? 10/8. Only 2 hours I can use this IP address. Then my system will have to request again for a new IP address. Okay. This is clear. And once the acknowledgement has been done, now the client will have the IP address provided by the server. So now after this particular point of time, your client can use the IP address. Is it clear? Okay. So what are the benefits of using DHCP? First thing, centralized management of IP address. Means even if there is one router, you have 2 LAN networks. Let's say this is 10.0.0.0. This is 20.0.0.0. So to both these networks also, you can assign IP address from single one device. Okay. And the entire database to which system what IP has been assigned, you can check on this particular device. Okay. So this is centralized management. You don't have to worry about taking all the information on the paper. Okay. Then ease of adding new clients. Now again, if you add new clients, what will happen? Automatically IP will be assigned. You don't have to worry about, okay, what is the next IP free, which IP I have to assign. There's nothing. No need to worry about. Why? Because your DHCP server, they'll go for automatic IP and your DHCP server will assign automatically the new IP. Then reuse of IP addresses, reducing the total number of IP addresses that are required. So again, if at some point of time, let's say system with IP 50 and 51 were removed. So now your server has the information that 50 and 51 is free. So whenever new client is added, they will get the 50, 51 IP. IP address will being reused. Simple reconfiguration of the IP address space on the DHCP server without needing to reconfigure on each client. Okay, understand this point, very important and interesting. How? Let's say right now I'm using this 10 network and this side I'm having 1,000 systems. Okay. So now consider case of first, if you do not have DHCP server, you have assigned IP to 1,000 systems anyhow. You have gone to each and every system and assigned the IP address. Now your company says, we do not want to use 10.0.0 network. We want to use, let's say, 30 network. What will happen? They want to change the network. What will happen? If you do not have the DHCP, go to the 1,000 systems, reconfigure the IP again. And what will happen if you have the DHCP server? Just in the DHCP server configuration, remove the 10 network, add in the 30 network. That's it. Your client will request the IP. They will get the IP. You don't have to worry about it. Means your task is what is happening? Getting easy, right? So this is simple reconfiguration. Means if you want to change the network, reduce the network size, increase the network size, all the benefits are there in case of DHCP. And the biggest benefit is centralized management. You don't have to worry about, or you don't have to look for which IP address I have assigned to what system, because your server will automatically capture IP address and like it will create a database. It will bind the MAC addresses with the IP addresses. So you'll know this MAC address is having this IP. Okay.
So it is for both private and public.
Yes, DHCP works for both.
basically binding database to like only the MAC address and
Yes, MAC address and IP address, and there will be information how it is learned, how it has been assigned. You'll see.
the port address is below.
No. Port address will not be there. Port address information will see. If you see the clients, sorry. So the clients, all clients are attached, or 1,000 clients are attached to single interface. So will they be given to the same interface, right? Port address information will be on the switch, which MAC address is on connected to which port, the MAC address table. Okay. Okay. So let's see how to configure this DHCP server. This is one router that will be using as a server, and 3 other routers will be using as clients. So this system will consider as PC1, and this one as PC2, and this one as PC3. So to PCs, we'll assign the IP addresses automatically. So we are not going to assign any IP address to these systems. We'll just assign one IP address on our DHCP server. Okay, let's say we want to use the network 10/22. So here I'll assign the IP .1. So go to the DHCP server and assign the IP address. No, enable configure terminal. Hostname will set DHCP. So interface Z0/0. IP address will be 10.0.1.255.255.255.0 and no shutdown. This is done. Clear? So this is normal IP configuration. This is clear, right? Okay. Now we'll configure DHCP server. So to configure DHCP server, you have to go to the global configuration mode. In the global configuration mode, you have to say IP DHCP pool, and you have to give any random name, whatever name you want to give. Let's say I want to give CCNA. Okay. We have created a DHCP pool. Now in this pool, we'll say which network IPs we are going to assign. So you're going to say network, and let's say I want to assign the 10 network IP. So this is the network. What is the subnet mask? 255.255.255.0. So with this configuration, your server is only going to assign IP addresses. If you want to, means IP address and subnet mask. If you want to assign default gateway also, so you have to say default router, because default gateway is basically the router IP only. So you'll say default router and the IP address of the router 10.0.1. Let's say you want to assign DNS server information also. So you'll say DNS server 8.8.8.8, the universal DNS, Google DNS. Okay. This is done. This is complete DHCP configuration. Now your router is behaving as a DHCP server. Okay. Your router will start behaving as a DHCP server with these 2 commands only. You don't require many commands. But this is some extra information that we want to assign with the help of DHCP server. So we have provided these 2 more commands, because your clients are going to need the default gateway to access the internet or to connect to the different network. Okay. This is clear. 4 commands only. Okay. Now we'll go to the PC1 CLI. Say no. Enable configure terminal. Hostname I'll set PC1. Now I want that my system, my PC1, should be behaving as a PC. My router should be behaving as a PC. So we have a command, no IP routing. Okay. So we'll disable the routing features. Okay. Now what do we want? We want that this system or this router should receive the IP address from the DHCP server, right? So your PC1 should receive the IP address from DHCP server. So go to the interface and say IP address. And instead of providing the IP address, you'll say DHCP. Instead of providing the IP addresses, you'll say DHCP. Hit enter. Still the interface is down, no shutdown. This configuration you have to use this one only if you are using your router as a client. Okay, specifically this one command, because this one command, it is going to assign the IP address to the router with the help of DHCP server. Okay. If you are using Windows systems or Linux systems, then you just have to go to your network manager. Okay. Then open your Ethernet connection or whatever connection you are connected to. Then you'll go to the IPv4 configuration, and then you'll find obtain an IP address automatically. That's it. When you click on this, your system will generate a discover message to check whether the DHCP server is available or not. Okay. And you see, automatically assigned, right? Interface Z0/0 assigned DHCP address 10.0.0.2 and subnet mask 255.0.0.0. Okay. Check show IP route. To show IP route. Okay. It is not taking the default gateway information. So let me add one client also so we can see. If you are using PC as a client, your PC will receive all the information. So if you go to the PC desktop IP configuration and DHCP, you'll see your PC will receive all the information, the IP, the subnet mask, the default gateway and DHCP server. Is it clear? Okay. Now we are supposed to see all those 4 messages, all those 4 DORA messages, discover, offer, request and acknowledgement. So what I'll do, let me connect one more PC so that we can see all the informations. Okay, I'll use this system. Connect to the switch. So you see, I'm keep on adding the new systems and they are automatically receiving the IP. I do not have to configure anything, right? Okay, so what I'll go to the simulation mode and right now I just want to see the DHCP messages. That's it. So I'll clear all the filters and just want to check for the DHCP. Desktop IP configuration and DHCP. First message. Which message it will be? Discover message. And you can see it is a broadcast message. All Fs. Okay. Source IP is all zeros, means we do not know about source IP. And destination IP is 255. Correct? This message is going from the client, so port number 68, going to the server, port number 67. And DHCP is a layer 7 protocol. Okay. Huh? Yes. 250 by 255. This is the highest address, universal broadcast address. Okay. So your switch will broadcast this message to everyone. And they are not going to accept it. But your server is going to accept this message. Now your server is going to reply this message. And if you see this message, this is the Ethernet and IP header. Just forget about this. Focus on the DHCP field. Which IP address your server wants to assign? 10.0.0.4. Then server address is 10.0.0.1. Okay. This is the client hardware address. So it is going to assign this information. You see, DNS server information 8888. So it is telling the server that I can assign you this IP and this is the information I can assign you. Okay. And again, if you see, this message is a broadcast. So this will reach the client. They are not going to accept it because they haven't requested for the IP. It is going to accept. Now next, what is going to happen? It is going to make a request. So the DHCP client receive an offer packet, construct and send out a request packet. Again, request packet is a broadcast. Okay, and it will show the acceptance to the server. And if you check on the DHCP server, show IP DHCP binding 10.0.0.2 and 10.0.0.3. These two IP addresses it has assigned, right? But it has not assigned 10.0.0.4 yet. There is no entry for 10.0.0.4. Why? Because it hasn't received a request. The request packet client has generated but not received by the server. Once your server receives this request packet, it is going to make an entry in the database. Correct? And now still your client doesn't have any IP address, you can see. Once this acknowledgement packet, if you see this packet, the DHCP server sends out an acknowledgement packet to the host. So once this acknowledgement packet reaches the client, still this is a broadcast message. Then your client will start using this IP address. This packet reaches the client and you'll see there's the IP. Is it clear? Any doubts in the DHCP? Right? We have seen the theory. We have performed the practical. Everything is clear?
More than 2 DHCP servers.
Yeah, then what will happen? In that case, whichever the DHCP server request or offer reaches the client first, because the main important thing is the offer message. Whichever offer reaches first to the client is going to respond accordingly. Okay, client is going to accept that particular offer message. It is not going to accept the second one or not going to check. Okay. Backup DHCP server. Yes. Same thing. If one is not working, then clients will accept the DHCP request from other system, other server. Yes, configuration will be the same. Okay. This is clear. Any doubts in the DHCP? No. So configuration of DHCP. In the global configuration mode, you are going to say IP DHCP pool and you'll give a random name. And then you'll say network and you'll give a network ID and subnet mask. This is the network from which you want to assign the IP addresses, right?
At the time we can set
In a single router, you can create multiple DHCPs. Yes, in a single router, you can create multiple DHCPs. This concept we'll be seeing when we are studying about DHCP relay agent. Okay. Like I said, let's say if you consider this scenario that you have one router, then you have two networks. So now you want DHCP for both these networks. So let's say if this side 10 network is being used, if this side 20 network is being used, so you'll create two pools, let's say A and B. In the A, you will configure the network 10 and subnet mask 10, default gateway 10, and DNS server. In the 20, you'll configure network 20, subnet mask, then gateway 20, and DNS server. 2 pools. Okay. So your router is going to assign the IP addresses accordingly. How router will know which side it has to assign what range IP addresses? This might also be a question. That this side I'm using 10 network, this side I'm using 20 network. So how my router will know whether this side I have to provide 20 IP and this side I have to provide 10 IP. So remember, you will give IP addresses to these interfaces. So the same range IP addresses your DHCP server is going to provide. Okay. Yeah, backup DHCP you can have, no problem. Let's say in the same network, let's say, for example, I have a switch. With the switch, I have connected 2 routers. So now if one router goes down, I still have second one, right? Same. See, again, configuration according to
but like the time they are now working on clearly.
SC. As soon as DHCP fails. So DHCP fails means what will be the problem? First of all, understand the problem. So if the DHCP fail, the client will still use the IP as long as it has the lease. So they will have internal communication, no problem. Now you can say the default gateway will go down. For default gateway redundancy, we have FHRP. That's it. Yes. Now next time, let's say when your clients are going to request for the IP after the lease expire, so they are going to start with the second. They will take the second offer. Correct? Is that clear? Then for default gateway information, you can say default router, and you can say gateway IP. And then for DNS server information, you can say DNS server, and this you can give DNS IP. This is your configuration for DHCP server, or you can say DHCP configuration on router. And if you want to make a router as a client, for that, you'll go to the global configuration mode. You'll go to the interface, whichever interface you want to assign the IP. So you'll say interface name and number. And after this, you'll say IP address, DHCP, and then just give the no shutdown. That's clear. About DHCP, we still have 2 more concepts. One is the DHCP relay agent, and one is the DHCP snooping. That we'll be discussing in a further class. Okay. Any doubt about regarding the DHCP? No? Online people?
Sounds good.
Okay. So next we have DNS. Okay. What is DNS, guys? Domain name system. Sometimes you'll say domain name system, domain name service. So why we require DNS? IP to name resolution. So why do we require these resolutions? Basically, we are saying that whenever DNS comes, we say IP to name resolution. But why do we require this resolution?
Difficult to memorize the numerical.
Okay. Your DNS is something like your contact book. Your DNS is something like your contact book. See, if you do not have contact book feature in your phones, still you will be able to make calls and receive calls. There will be no issue. But every time you want to make a call, what do you have to do? You have to remember the person's number who you want to call. Every time you'll have to go and type in the number. So how many persons' numbers you can remember? That is the scenario. That how many people's number you can remember? 1, 2, 5, 10, 20 max to max, not beyond that, right? Okay. Now, if you have a contact book, how many people's names you can remember? Can be a big number, right? Can be a big number, because if you see in our family, in our relations also, we have 20, 50 people, 70 people, right? And we remember the names of each and everyone. But do we remember the numbers? No. So this is the same thing with the DNS service. If we are using the internet, we just always go and say google.com, facebook.com, Instagram, Cisco, YouTube, right? But do we remember the IP addresses? No. How many IP addresses we can remember? Okay, I'm not saying like, okay, you go with the 192.168.0.1, 0.2, 0.3. No, this is not something like that. Because your websites, they are being hosted on public IP addresses. Okay. So if you consider, let's say, let's check some IPs. So I'll go to the command prompt. And I'll say, first of all, ping google.com. Okay, let me take a notepad. Okay. So I'll say ping google.com. So I have received the IP of Google. Next, let's go with Cisco. So I'll say ping cisco.com. This is the IP of Cisco. And then let's go with YouTube. So YouTube is from Google only, so you will see the same range. And one more, let's go with Twitter. These are the 4 IP addresses. Which one is easy to remember, name or the IP address? Name, obviously. Name you can remember in seconds. And these IP addresses, I'll give you 5 minutes and you'll forget after some time, right? So basically, we are used for the names, not for the numbers. We never like math and numbers, right? So this is the reason, this is the facility provided by your DNS server, that you can remember the websites by their name. You can access the websites by their name. You do not need to require to remember the IP addresses of each and every website you visit. Because if you had to remember the IP addresses, you might be limited to 2 or 5 websites at most. You might be limited to 2 or 5 websites, because every time, let's say, if you get the same IP address, if you go with the Google and YouTube, so they both starts with 142, 250, and you'll get confused. There is a chance you'll get confused, right? So this is the thing that happens. So we have this DNS service. What it does, anytime you go to the browser and say google.com, first of all, your system will go and check for the DNS server. Okay. And even before going to the DNS server, it is going to check the DNS cache, because your browsers also has the cache information. Okay. So it is going to check the DNS cache, whether I already have IP for google.com. So if it has the IP, it will directly make a new request to the IP, because ultimately all the network devices in the network, they are identified with the IP address. So for proper communication, we are going to require IP address. This DNS information, this is just for our comfort. Okay. So if there is no entry in the DNS cache, let's say no entry in the DNS cache, then what is going to happen? They are going to check different DNS servers. There are 4 types of DNS servers. Okay. So one by one, they are going to ask each and every one. Clear? After that, what is going to happen? One of them, the final of them, that is the authoritative DNS server, that is going to provide you basically the IP with. And then your system will not communicate more with the DNS, and it will start making the request with the IP. So we'll see what are these 4 types of DNS servers and how this DNS process is exactly happening. Okay. Because if you do not have the DNS servers, your internet will stop, because everyone is trying to access with the names. Okay. So first of all, what is DNS? DNS means domain name system, and it resolves names to IP address and vice versa, means IP to name and name to IP. Okay. So DNS is an application layer protocol, works on port number 53 and uses both protocols TCP and UDP. Okay. And this is a question for you guys. When your DNS uses TCP and when it uses UDP, this you will make a research today. Okay. You'll go and search when your DNS server uses UDP and when it uses TCP, because this question can be asked in the interviews. Okay. Clear? Port number is 53, both for TCP and UDP. But sometimes it uses UDP and sometimes it uses TCP. Okay. So tomorrow we'll discuss about this and you tell me. Okay. There is a very small concept, very small reason behind this. So this is clear. Now there are certain types of DNS server. First is the DNS resolver. Second is the root name server. Third is the TLD server. And fourth is the authoritative name server. And each and every name server or each and every DNS servers, they are having their own specific task. Okay. So this is how a computer loads a website using DNS. What happens when you access a website, when you go and say google.com, facebook.com. So let's say this is my system and I'm saying facebook.com. Now my system, it is going to check for the cache. If there is information in the cache, well and good, I'll directly make communication with the IP address. If there is no information in the cache, first of all, I'll go to the DNS resolver. You remember you give the IP 8.8.8.8, the universal DNS. Okay. So the request goes to the DNS resolver. If the DNS resolver has the IP, it is going to provide you the information. If it does not have the IP, then it is going to check, first of all, that what you have typed. So you have typed facebook.com, facebook.com. So this .com, .in, okay, these are root name servers. These are top level domain. These are top level domains. So what happens to these top levels means very popular, unique. So your DNS resolver is going to send you the IP address of the TLD name server or root name server. This root name server is basically kind of a book that is having the information. Okay, this particular server is having .com or .com information. This particular server is having .in information. This particular server is having .uk information. Means, see how these have been divided. That there will be the actual website is facebook.com, right? Now, if some system is not having the information, first of all, there is a book that is having the IP address of the server that is having .com information, IP address of the server that is having .in, .uk, like this. Okay. So whenever the request goes, it will check, okay, .com means give this IP address. You will find the information on this particular IP address. So you will get the IP address of .com TLD name server. Now you know where to go. Your system will make a request to the TLD name server. Again, your TLD name server is a book. Okay, it has the information for Facebook. For Facebook server, this is the IP. For Google server, this is the IP. Okay, and then for some, let's say, other server, Twitter server, this is the IP. So it will provide you, okay, it will check, okay, Facebook. So I have to give this IP. You will get the IP of the authoritative Facebook server IP. Now, the Facebook server, it is going to give you the exact information of what is the IP address you're looking for. This will have the information of the exact IP address you are looking for. And finally, you will get the address to this particular website, because Facebook server will be hosting multiple websites and there will be multiple servers available under the Facebook. Okay. So they will give you the exact IP address. Once you get the exact IP address, your system will stop communicating with the DNS server, and then it will directly make communication with the Facebook IP, and you will access the Facebook server. So ultimately, your communication is happening with the IP address only. But this DNS server, these four types of DNS server, they are just helping you to get the IP address, so that we don't have to remember the IP addresses. Okay. First is the DNS resolver. Okay. That is going to help you get the DNS information. It is going to resolve your DNS server information. Okay. Root name server has the information about top level domains, all the top level domains. And the TLD name server has the information about authoritative name servers. These authoritative name servers has the exact information you need. It's something like, you can say that this is your principal. This is your principal of a university. So if there is an inquiry for some student, the principal is going to say, this student belongs to that department, you contact to that particular department. Now, this department is going to say, this particular person is the HOD of that department. So you contact that person. He will give you more information. And the HOD will give you the information of class teacher. This class teacher has the exact information about the student. And this is how you get the information step by step. Okay. So they will keep forwarding, because if there is only one server hosting all the top level domains, authoritative servers, that will be getting a lot of requests, and internet will not be able to fulfill, or the one server will not be able to fulfill all the requests of the world, right? So even we are having multiple DNS servers in the world, not just one. There are a lot of DNS servers working together. There are some lot of root name servers, TLD name servers, and authoritative name servers. And this is how the internet registry is working, how we are using the internet. Is it clear? For DNS, I cannot show you practical because there's no configuration. Okay. You can configure DNS server in your router, but this is not for CCNA. Yes.
Actually, when it becomes servers,
Huh?
who all manages this kind of?
There are different kind of organizations. Like Google is having their own 8.8.8.8, 4444, 4422, 8844. So there are organizations that are managing these internet or DNS servers. Okay. Even you can have a local DNS server in your company. Let's say, simple example I will give you. This is my company network. Okay. And there I'm using a server. So in the server, I'll configure a local DNS server. And let's say this system, it is used by Ramesh. This is used by Suresh. And this is used by Shyam. So instead of remembering the IP 10, 20, and 30, I'll start communication by the names. That's it. If I want to ping this system, I'll say ping Ramesh. If I want to ping this system, I'll say ping Suresh. So this becomes more easy, because instead of remembering, okay, what is his system IP address, I'll remember his name, right? So in the DNS server, you'll configure that if it is .10 IP, I'll use the name Ramesh. So whenever you give the name Ramesh, your DNS server will resolve it and give you the IP address, and your system will start communication with the IP address. Okay. Is it clear?
The router itself, or we have to use
Servers, like you can use Windows servers, Linux servers. Okay. Any more doubts? No? Online people?
No.
Okay. Next, we have FTP and TFTP. These are the two protocols used for file transfer. Okay. So your FTP stands for file transfer protocol. This type of protocol is used to transfer or copy files from one host to another host. Entire internet downloading and uploading, that is happening on the FTP. And in FTP, secure channel is provided. See, again, these are like this is your SSH, this is your telnet. Same thing. Unsecure. Okay. And this is secure. These are similar to that only, like this is your SSH and this is your telnet. So in FTP, secure channel is provided to transfer files from between the host or systems. FTP works on two ports. One is the 20 and second is the 21. Okay. So out of them, one is for data and another is for connection control. And mainly your FTP will be using port number 21. Is it okay? Okay. Then we have the TFTP. TFTP stands for Trivial File Transfer Protocol. Okay. TFTP used to transfer a file either from client to server or server to client. In your TFTP, we do not require any kind of usernames and password to verify. In your TFTP, you do not require usernames and password to verify, but in your FTP, you are going to require. Okay. Even your FTP server, you can configure as an anonymous, like anyone can access, but you can secure your FTP server. But TFTP, you do not require any authentication. So TFTP is used to transfer a file from client to server or from server to client without the need of FTP feature, means without authentication and security. Software of TFTP is smaller than FTP because less security, less features. TFTP works on port number 69 and service is UDP, unreliable. Okay, so your TFTP transmissions can fail, but your FTP transmissions are not going to fail. Is it clear? So FTP, this will be using, will not be having a practical for FTP. I'll be showing a practical for TFTP. This TFTP practical we'll be doing for taking backup and restore of configurations and router IUs. So today we'll be seeing how we can take backup and restore the IUs of your router or the configurations of the router. This is clear? Okay, first let's see the differences, then we'll go for the practical. So what are the differences? FTP stands for File Transfer Protocol. This is Trivial File Transfer Protocol. Software is larger because more features. Software is smaller because less features. Then port number 20 and 21, port number 69 uses TCP, Telnet uses, TFTP uses UDP. Then complexity of FTP is higher, complexity of TFTP is less. Automatically, because if you are having more features, you'll have to do more configurations, means more complex. Then in FTP, you have several commands to configure authentication and then to have secure channel. But in TFTP, only 5 messages are sufficient to take restore. I mean to restore your IUs. FTP need authentication. You will have to require usernames and password. But TFTP does not need any authentication. FTP is generally suited for uploading and downloading files by remote users, like we are downloading from the internet or uploading something on the internet. But TFTP we require for configuration, for transmission of configuration from to and from network devices. If you want to take backup of the configuration, if you want to restore the configuration, for that purpose, we will be using TFTP. Then it is using TCP, right? So reliable. UDP means unreliable. FTP is slower. TFTP is faster because TCP is comparatively slower than your UDP, right? So your FTP will be comparatively slower than UDP. I mean TFTP. Is it clear? Okay. Shall we go for the practical? Oh, noted. So for this purpose, I'll just take 2 devices. One will be your router and second device will be your server, where we'll be taking all the backups. Okay. To the router, I'll assign the IP 10.0.0.1. To the server, I'll assign 10.0.0.2. 10.0.0.2. And to the router, I'll assign 10.0.0.1. Interface is 0 by 0, IP address 10.0.0.1, 255.0.0.0, and no shutdown. Okay. Check the communication. Ping 10.0.0.2. Have the communication, right? Correct. Okay. Now, next, what we have to do, we have to configure the TFTP server. So go to the server services and you'll find TFTP. So if you see here, there are already some image backups already available. So what I'm going to do, I'm going to remove these backups so we can see whatever we are backing up is coming into the server, right? Nothing, all clear. And the TFTP service is on. And let's say I'll change the host name of the router and make some configuration. We have given the IP addresses. I'll change the host name. Let's say host name, I'll say R1. And also let's say I'll set enable password 1, 2. This is the configuration I have done in the router. Okay. So right now I'm having 2 configurations. One is my running configuration. So you can check, show running config. So I have the running configuration. Do I have the startup configuration? No, because I haven't given the right command or copy running configuration to startup configuration command, right? So let me give the right command. Now I have the startup configuration. First of all, I'll try to back up these 2 configurations in my server. So how you can back up? You'll say copy. Now you want to configure, copy the running configuration. So you'll say running configuration. And where you want to copy? TFTP. You want to copy your running configuration on the TFTP server. That's it. Hit enter. Address or name of the remote host means server IP. Is it server IP 10.0.0.2? Hit enter. Now, what is the destination file name? With what name you want to save the file? Let's say I want to save it with the R1 run, means R1 running configuration. Hit enter. Let's go to the server and check. Do you see we have a file here, right? Okay, next we'll take the backup of your startup configuration. So same command, you have to say copy your startup configuration. Where you want to copy? TFTP server. Hit enter again, give the IP 10.0.0.2. This one, let's say I'll say R1 start. Done. Let's check. It is there. Okay. Now how to restore the configurations. So what I'm going to do, I'll erase the startup configuration. So I'll say erase startup config. Confirm. If you check, show startup config. Not present. Now I'll directly restore my startup configuration from the TFTP server. So we'll just give the reverse command. We'll simply say copy. This time we want to copy from TFTP server. And where we want to copy? Startup config. Hit enter. IP of the server is 10.0.0.2. Source file name. What is the file name on the server? R1 start, right? Hit enter. What is the destination file name? Startup configuration, because we want to copy in the startup configuration only. Hit enter. Check. Show startup configuration. We have the configuration. This is how you can restore. Okay, next we'll go for the running configuration. Okay, so first I'll erase the startup configuration again. And I'll reload the router. So my running configuration will go on, right? Now I will not have any configuration in the NVRAM and RAM. So I will see system configuration dialog. When you do not have any configuration in the NVRAM, you'll see system configuration dialog. And you see the system configuration dialog. We are going to say no. Now I want to restore my running configuration, right? But for connectivity, I will need some IP. For connectivity between the router and the server, I'll need some IP, right? Right now, if you see, I do not have any IP address on the router. Show IP interface B. And if I do not have the IP, I cannot communicate with the server. So right now, I'll assign any random IP, configure terminal, interface 0 by 0, IP address 10.0.0.100. I have assigned a random IP just so that I can communicate with the server and restore my configuration. So my host name was R1. My IP address was 10.0.0.1. Correct? So as soon as I restore my configuration, you will see that all my configuration will be back. Means this IP will change automatically and this host name will change automatically. Okay. So check. Do show IP interface brief. Right now, this is the IP and this is the host name. Correct. Let's go and restore the running configuration. So I'll say I want to copy from TFTP server to my running config. Okay. Hit enter. What is the server IP? 10.0.0.2. Source file name. So it is R1 running configuration. Hit enter. Destination file name. You want to copy in the running configuration only. Hit enter. R1. Before it was router, and now you see R1. Before the IP was 100. If I check, show IP interface brief. IP also changed. And we also set enable password, right? So if I say disable command, or let me just directly go exit, all the configuration is back. So this is how you can take backup and restore of your configurations. Simply the copy command will be used from where you want to copy and where you want to copy. From and to, source and destination. That's it. Okay. Online people, configuration backup and restore is clear?
Yes.
Okay. So I'll remove the password so that we do not face any problem. Okay. Now last thing remaining is to take backup of your IOs and then restoring it. Okay. So first of all, we must know where is the IOs. So where your IOs is available. Next. Flash memory. Okay. To take backup of IOs, we'll need the name of IOs file, right? So either you can check the IOs name with the command show version. If you hit this command, this will give you information about your Cisco IOS software. This is the router series. Okay. This is the version of your IOS. Okay. And here you'll find system image file is. So whatever you see in front of flash colon, that is your IOS file name. Either you can find like this, more easy way. You can simply say show flash. And in here, whatever file name you see with the .bin extension, that is your router IOS. Okay, so just copy this name. And now again, use the copy command. Copy, this time I want to copy from flash and I want to copy at TFTP. Again, source and destination only. What is the source file name? Which file you want to copy? I want to copy this file. Okay, address or name of remote host means 10.0.0.2 server IP. Destination file name. On the server, what name you want to save? Let's say I want to save R1 IOS, right? Hit enter. Exclamation mark means success. You see, written. Check on the server. R1 IOS. Now let's say due to any reason, due to any mechanical, electrical or any kind of failure, your Cisco flash memory is damaged or your IOS is corrupted. Now in packet tracer, we cannot damage the IOS. We cannot damage the flash memory or IOS, but we can do one thing. We can delete the IOS. So router will not have the IOS and will directly boot into the Roman mode. Okay. So see, I'll simply say delete and the name of the iOS. Do not try this in the real game, okay, or in the production environment. Just keep on hitting enter and give the reload command. It is asking whether you want to save the configuration. We do not want to save the configuration. Proceed with the reload and you see which mode we are in. Roman mode. Why? The system is unable to boot automatically. So your boot process has been interrupted because your router is not having the iOS. So now we need the iOS. We know that the iOS backup is available at the server. So what we can do, we'll give a command. So you are going to require some parameters to restore. But what are the parameters? If you know, well and good. If you do not know, you give this command tftp dnld, tftp download. Once you give this command, hit enter. This command is going to say, these are the parameters you are going to require to specify to use this command. So first parameter is IP address. Second is IP subnet mask, default gateway, TFTP server, and the TFTP file. These are the 5 parameters you're going to require. Okay. And you have to keep in mind that they should be in the same case and same format. Okay. Means first is the IP address. Means you have to assign again temporary IP address to the router to communicate with the server. Subnet mask, same thing. Default gateway, also same. Then we have to provide the TFTP server IP and the file you want to download from the TFTP server. This is the information we need to provide. Okay. So one by one, I'll say IP underscore address. Let's say I want to assign this time 200 temporary IP. Then I'll say IP underscore subnet underscore mask, and the mask we use is 255.0.0.0. Then default gateway. You can provide anything. I'll just go and provide server IP only. Then TFTP server information, TFTP underscore server equals to, again, our server IP is 10.0.0.2. Now the file we want to download. So TFTP underscore file equals to, and TFTP file name is R1 iOS. This is the name. Hit enter. Now all file parameters, the required parameters have been set, right? Okay. So then you can again give the command TFTP download. Hit enter. Once you hit the TFTP download command, it is going to show you whatever configurations you have done, right? And it is saying invoke this command for disaster recovery only, right? Because this is going to wipe out your entire flash memory. Whatever is there in the flash, it is going to wipe out and then new iOS will be installed. Okay. But still we want to do it. So we'll say yes and enter. And now your router is going to communicate with the server and you see, we are seeing exclamation mark means success. Done. Once you are done, give the reset command and you see your iOS is booting. This is how you can restore your iOS from the TFTP server.
How do you get random IPs?
You know the network, right? Which network is running. So you can give any IP from that network, up to you, right? Because we know that server is in the 10 network. So we have to be in the same network for the communication. So we have to provide the IP.
You can't give any different.
You can give if you have a default gateway in between, router in between, right? That's why it is asking for IP, subnet mask, and default gateway information. So that anyhow it can communicate. Okay. And these configuration, you can sit anywhere in the network and do it. But when your router is not having the iOS, you will not have the telnet and SSH access. Again, you have to do what? Console cable, right? So this is the times when your console cable is required. Clear? So backup and restore of iOS and configurations clear. What are the parameters you have to assign? The parameters are IP underscore address. See, if you give the TFTP download command, it will automatically show you all those 5 requirements. Okay. So you can check.
So the TFTP server should be on with that.
Yes. Not directly connected. This is just like, I do not want to design a big network. Your server can be at any place. Your router can be in the server room or any other place.
If we want to build a new one, in that case, we require some physical needs to enter in that particular.
Yeah, console cable
And the server should be near.
should be in the network. Should be in the communication. We assigned the temporary IP address, right? IP underscore address, we gave the command. So router took this particular IP address to communicate with the server. Okay. Once communication is done, then it is going to restore the iOS. And once iOS is done, it is going to reload the configurations and everything.
So without how iOS, Roman have that
Yes. Roman mode is something like your BIOS. If you do not have Windows, you can install it through the network if you have the BIOS. We have the network boot option, right?
First thought if iOS is not have any able to
No. It will be able to communicate. See, your router is just similar to your system. One difference in the router is it is providing communication between different networks. And your PC doesn't do that. Otherwise, if you see, It has the RAM also, ROM also, and it has the hard disk also, processor also, everything it has, same devices, right? And if you see in your packet tracer, your router and PC, they are considered as same device. Which cable? Cross cable. Okay. So they are considered similar, means they transmit and receive on the same pins. Is it clear? Online people?
So the random IP address you assign has to be in the same subnet.
Yes, it has to be in the same subnet, or you must have a default gateway in between.
And if you do that, then you don't need the cancel cable.
Yeah, we do not need the console cable. No, console cable will need to access the router, because right now we are directly accessing it in the packet tracer. But in real scenario, what you're going to do, your network will be something like, you'll tag your laptop. Okay, then you'll connect your laptop with the help of console cable. Okay, then you'll go to your laptop. In the desktop, you'll go to this terminal, like your Putty software, and you'll say okay, and you'll have access to the device. Okay, this is how you're going to access.
Okay.
Okay, this will be in the RS-232, and now you'll see this is. I have the access to the router. So you're going to need the console cable to access the router. This particular Ethernet cable is for the communication between the router as well as the server. Okay.
Okay.
All right. So any more doubts? Yes.
There is no way to get console and remotely.
You have? Yes, you connect this. See, you connect this console cable with the console server. The console server can have the IP like your lab, and you can have the remote access. Okay. Apart from that, you cannot. Or what you can have, let's say a system is connected in the network or with the help of console, or is in the network with the console server. You can take the remote access through the AnyDesk or all those softwares, and then you can configure the router. So there's always a possibility.
There should be a separate device.
Yes, there should be a device. Okay. Any more doubts? Online people? Any doubts?
Not.
Okay. All right, then that's all for today. See you guys tomorrow. Have a great day.